without any further ado, thanks to everybody that's joined, and for anybody that's going to join, thanks in advance. Just to kick straight off, today we're joined by Rafal from Hazelcast. Very happy about this one. For those that don't know, Hazelcast is the leading in-memory computing platform company who basically address the growing demand for enhanced application performance, speed, scalability, things like that. To my knowledge, their customers include 6 of the world's 10 largest banks and 36 of the Fortune Global 500. Its tech is deployed at nearly every major credit card company, 5 of the world's largest e-commerce companies, and 4 of the largest telco companies. So it's fair to say that Hazelcast is quite well known across the world. Rafal, I'll do my best to give you a quick introduction, but by all means, do it more justice in just a moment. So Rafal is an integration team leader at Hazelcast, also author of the book Continuous Delivery with Docker and Jenkins. He's a trainer and he's a conference speaker, so he's very well accomplished in this field. Specializes in a number of things: Java development, cloud environments, and continuous delivery.
My talk is titled Build Your Kubernetes Operator with the Right Tool. And I will present different ways for building the same Kubernetes operator. Usually I tell a few words about myself at the beginning, but thanks, Joe, for the introduction. So it was already mentioned. I'm a lead, actually now it's called Cloud Native team at Hazelcast. And yeah, I do training and conference speakings from time to time, but on a daily basis, I do coding. So that is my daily job. Few words about Hazelcast. It was mentioned about leading. It was mentioned by Joe about leading in memory, data grid. So we are a distributed company, and we are distributed in 2 meanings. First, we are distributed because we produce distributed software like Hazelcast in-memory data grid, which is for any in-memory computing. We also have Hazelcast Jet, which is a stream processing platform. We also have Hazelcast Cloud, which is Hazelcast put as a service. But we are also distributed because we all work remotely. Even before this 2020, we work remotely, so we are located everywhere in the world, which is quite an interesting setup. So our agenda for today is pretty simple. I will first talk shortly about the operators in general. What is operator? Why do we build it? And then I will walk through all possible ways that you can use for building an operator. So I will cover operator SDK and the free methods it provides: Helm, chart-based, Ansible-based, and Go-based. I will talk about different operator frameworks, and I will also mention how you could implement operator from scratch using any programming language you want. So let's start with the introduction. So the introduction point for us is you would like to build an operator. You need an operator for your software to run on Kubernetes. So now you may wonder which language, which technology to choose. And that is what it will be about. So we start let's start with what the operator is. So Kubernetes operator is an application that watches a custom Kubernetes resource and performs some operations upon its changes. So this definition is very generic, as you see, because the operators themselves are generic. They can do a great variety of things. So to make it more digestible, let's focus on one example of an operator, and we will use the same example throughout this talk. So this example will be a Hazelcast operator. So we would like to build an operator which will create Hazelcast cluster for us. So from the user perspective, you are a user, you would like to use Kubernetes or OpenShift cluster, and you would like to specify a configuration like this. A Kubernetes resource, and then apply this configuration. And that's it from the user's perspective. That is all you need. You would like to, after applying this configuration to Kubernetes, you would like to have a hazelcast cluster ready. And the only parameter we have for this super simple example is a cluster size. So how many hazelcast nodes there will be in the Kubernetes cluster. So then our operator, so this is from the user perspective. As a developer, I just set it up. I would like to have hazelcast cluster. So our operator in these scenarios will be an application that watches hazelcast resource. So users modifies hazelcast resource, and our application will be an application that watches this hazelcast resource and detects the changes. So it listens to the change events, and when any change occurs, it adjusts the state in the using Kubernetes API to the Kubernetes cluster. So this is a super simple example because we just have one parameter in our resource configuration. In the real life, the operator can do a lot of different things, like cleaning that. For example, like it could clean up the data in hazelcast cluster, or it could upgrade the version, or send some data, or perform some geo-replication. So whatever you can imagine. Now, since operator is just an application, usually Dockerized application running on Kubernetes, we can actually write it in any programming language we want, in any technology you want. It's enough if you write it, Dockerize, that's it. Also, Kubernetes itself, it provides a REST API, so you could run it, you could implement it in whatever technology you want. Nevertheless, no matter which technology you choose, there are some things that operators have in common. So you always need to build them, Dockerize them, install them into your Kubernetes cluster, and then use them. So you always will have the similar steps, like you first to implement the logic of the operator. So this is our business logic, what the operator will do. Then to Dockerize it, because usually, it's not a must, but usually operator will be in a form of a Docker image and a Docker container running in your Kubernetes cluster. Then you always need to create your custom resource definition. So this will be, okay, how my resource should look like. And then you need to define what are the requirements, what are the permissions that are necessary for your operators to do the job. For example, it needs to use Kubernetes API to create hazelcast pod. So it needs to have this permission. Then you will always need to deploy your operator into the Kubernetes cluster. And finally, the last step is what usually, all other steps is what developer of the operator does and the operator of the cluster. The last step is always you have your definition and you apply it, your custom resource definition, and you apply it into your Kubernetes cluster. So this step will be always in every operator. So with that in place, we can see how to implement this operator logic, because this points from 2 to 6, they will be the same no matter how you implement your operator. The only difference and the only thing that we will describe, that I will describe during this talk, is how to implement the operator logic. So with this in mind, we can start the first option you have. So first option you have is to use operator SDK with the Helm tool. So the Helm tool is Helm is a package manager for Kubernetes, and it allows you to create a set of templated Kubernetes configurations, package them into the Helm chart, and Helm chart is just a package, Kubernetes package, and then render them using the parameters defined in a file called values.yaml. Helm is super simple because to implement a Helm chart, you don't need to know anything more than just standard Kubernetes configurations. So basically, Helm is a templated Kubernetes configuration that is filled during Helm install. So in our example, to create Helm-based hazelcast operator, we need to first create hazelcast Helm chart. So this is how to create hazelcast Helm chart. You use a Helm toolkit, create a chart, and then you fill all the templates you need. So in our example, if you look at these templates, they are just like Kubernetes configurations with some templated part. Like here, you see that the name of the deployment is filled automatically from the chart name, and the value size. This is one of our the only parameter we have. This what you see on the bottom is our values YAML. So it is the user parameters for the Helm chart. Now, if we have this Helm chart ready, then to generate an operator from the Helm chart, we use operator SDK toolkit, and we can basically generate an operator from the Helm chart using this command. So we init the operator, create an API, and then just docker build, docker push, make install, make deploy, kubectl apply. So these are these commands you will always use no matter which operator implementation you do. So to show you like a quick demo on that, I actually created, I will share you the link if you would like to try it on your own, a repo with all the options to create an operator, and one of them is Helm. And here you can see all the steps you need to generate an operator from the Helm chart. Now I have it in my VS Code, so we can look at the code. So here's our Helm chart. So Helm chart, what is interesting is exactly what we've seen on the slide. So this is our templated Helm chart. It looks exactly like Kubernetes configuration. That is why it is super simple. And out of then, I already did this operator init. And now what I need to do with these steps is to build a Docker image from that. So I basically now build an operator, push it into the Docker registry. Then make install creates the custom role definition for our operator. And then I deploy an operator. Deploy means I will pull this image I pushed into Docker registry and run it as a deployment in the Kubernetes cluster. And finally, it should be deployed. So here is the command where it's deployed. I can see the logs of the operator. So you see, operator is just an application. It was generated from the Helm chart. It prints a lot of logs. So this was done by like someone who implemented the operator. Now, what the user does. So from the user perspective, what you would like to see is only your resource definition, which is, by the way, also generated with this operator SDK. So our resource definition is created in the sample. So this is our resource definition. So what I wanted is that if I apply this resource definition, it automatically create Kubernetes hazelcast cluster for me. So if I apply this resource definition, exactly this file, you can see when if I apply it to my Kubernetes cluster, I need to switch to. If I apply it to the Kubernetes cluster, you can see that you should see in a moment that this operator listened for this change, and it made some changes to the Kubernetes API. And if I check what the pods I have in my cluster, you can see that okay, hazelcast cluster was created with one node. We could scale it up. For example, let's say, okay, I changed the parameter, I apply this change again. The operator should detect the change. Okay, it detected the change and should interact with the Kubernetes API. So you see, I have 3 hazelcast members. If you're interested, like in a like hazelcast logs, you can see that they should form one. Actually, they should form one consistent caching cluster. So that was the simplest one. To uninstall the operator, I need to uninstall my custom resource and the operator itself. So that was the first option, using Helm chart. Helm chart, if you look at the description at the operator SDK is developed mainly by the Red Hat, and if they provide something like capability levels, meaning if you create an operator from the Helm, you can provide some basic functionality, but you cannot do some very complicated stuff, which makes sense because Helm is limited to Kubernetes, to templating Kubernetes configurations. So you cannot do really like super complex custom things with this. So we are limited to some basic functionality. So what if you use this Helm approach with operator SDK, what does it mean to you? So first thing is your operator implementation is declarative and therefore simple. So it requires no more knowledge than just a standard Kubernetes configuration. If you already have a Helm chart, then it requires no work for you to generate an operator, which is actually our case in Hazelcast. We generate an operator from Helm because we just want to maintain the Helm chart. We don't want to maintain 2 things, so we generate an operator. Your operator functionality is limited to the feature available in Helm, and all this manifest configuration files, this role bindings, everything is automatically generated. So it's good for you. So you only need to maintain actually your Helm chart. Second option you have is still to use operator SDK, but this time we will use Ansible. So we will generate an operator from the Ansible playbook. So Ansible is a very powerful tool for IT automation, and its nature is declarative, and it has a lot of different plugins. That is the power of Ansible. And one of its plugins is called Community Kubernetes plugin, and it provides a way to interact using Ansible to interact with Kubernetes API. If you would like to create like a operator-based, Ansible-based operator for your software, then you need to do the following things. So you need to SDK init using the Ansible, and then your implementation will be in a Ansible YAML file. If you look at this, it looks very similar to the Kubernetes configuration. However, this time it's there is a slight difference, because the difference is that before this configuration, this Kubernetes configuration, it was directly consumed by Kubernetes. So it was really a Kubernetes configuration. Here it is used by this plugin, Ansible plugin, and only then passed to the Kubernetes API. So there is a subtle difference. But the idea is very similar to the Helm-based operator. How to do it is if you implement this, how to build it. It's actually, the steps are exactly the same. You build your Docker image, make install to apply all these configurations, this boilerplate configuration to your Kubernetes cluster, and deploy operator, and finally apply your resource. So this is a very similar example. The good thing about, like, if you are interested in running it on your own, I will share the repo at the end of this presentation, where you can play it on your own. Good thing about this Ansible is, comparing to the Helm, is the configuration looks very similar. However, Ansible is way more powerful than Helm, because Ansible is not only like Helm is just basically templating things. Ansible is much more. You can make really complex operation and like DevOps things with the Ansible toolkit. So you can do anything you want for your operator using the Ansible. So if you use operator SDK with Ansible, what does it mean to you? So your implementation of the operator is declarative, and therefore it's concise and human readable. YAML configuration is executed by the community Kubernetes plugin, and Ansible can cover all capability levels of the operator, which is good for you. And all this boilerplate manifest files, this role binding, the custom resource definition, they are automatically generated, so you don't have to do anything for them. The third option you have is to use operator SDK with the Go language. So the Go language is like, Go is general purpose programming language. It's not like Ansible, which is declarative manner. Go is just a programming language. So technically in Go you can write really any logic you want, because you can express anything you want. What's more, the Kubernetes environment itself is written in Go. So there is, if you interact with Kubernetes API, there is nothing better. There is no better client library than the one written in Go. So that is a big thing for your operator. And the good thing is that operator SDK supports implementing operators in Go. So you get a lot of scaffolding, code generation for free. That is, again, a very, very good thing. How does it look like? If you decide, okay, I would like to implement it in Go, how your code looks like. So this is like the part of the code, how it looks like in operator in Go. So again, you start your project with SDK init and SDK create API. Now you can already see that the code is actually way more complex than Helm or Ansible, because it's not declarative. Here you really write the code. So you have to cover all the cases, like, okay, even for our simple scenario, we just have one parameter, which is size. So you have to cover, okay, like, I really need to get it from Kubernetes. What is my cluster size? Okay, get it. Like, then prepare the deployment. If the size didn't change, you have to update it. So you really need to implement it in an imperative way, things your operator should do. One thing to notice here is that this first comment above the reconcile method is actually a comment, but from this comment, your role binding role definition is generated. So it's very convenient, because you write here the permissions that are required for your operator, and the operator SDK will generate you the proper YAML files. What you can see here is that apart from the fact that I didn't even list the whole code here, it's way bigger, but apart from this fact, you can see that like deployment spec is now not a YAML file, but it's more like kind of native. This will be the native expression of your deployment in a Kubernetes way. Because like, as I said, like a native Kubernetes client is written in Go. This hazelcast types is basically our input for the operator and the structure where the input goes. So definitely, if you go with the Go language, it requires way more implementation. It's actually way more complex. But the good thing is that you are not limited by anything, so you can even do some custom logic on your software. How to build it and use it? So it's still operator SDK, so the steps will be very similar. So you build your operator with Docker, and then make install, make deploy to apply all the CRDs and role bindings, and deploy the operator, and then you can apply finally your custom resource. I can show you in the code like how it looks like the whole Go project. The interesting thing is this is the whole project of most of the things are actually generated. The things that are interesting is actually your hazelcast controller. So controller is the main part. That is the business logic. So you can already see like there are a lot of things here. Like here is what I mentioned. Like from this part, your role and your permissions, required permissions for the operator will be generated. And you see there's like a lot of code to write even for such a simple operator, which does nothing more than create hazelcast cluster and scale it up or down. Because you really need to write, you know, all the error handlings, all the here you check the size, then you have to compare, like if your existing deployment has the same size. If not, then update the deployment. So you get the idea. You really write it step by step instead of writing in the declarative fashion, which is way more complex. Coming back to our slides. So if you use operator SDK with Go, your implementation is imperative and requires much more work and caution, error handling, and everything. However, like if you were to choose from all the languages, probably Go is the best language to write an operator because it's well integrated with Kubernetes. You have no limits on the functionality you would like to provide. And the good thing is that you use operator SDK, so your boilerplate files are automatically generated. Okay, we covered like the mainstream. Mainstream is using operator SDK, but not everyone walked this way. So there are other frameworks which can help in creating an operator. So I did like a research, like if you don't use operator SDK, what are your options? And I Googled a few tools for creating operators, tools written in different programming languages. You can find even a little more of them. This were what I found. So if you were to choose like which one you would like to try first, so what I usually do with libraries is check, you know, how popular they are. So one way of measuring the popularity of the framework is to check, okay, how many GitHub stars they have. From this, we can already see that, yeah, you better not go with the C# operator SDK, better not with Node.js, maybe Java, maybe Rust. The best one is probably this one from Python. And if we look closer to this KOPF framework from Python, we can see that this is a fork from, it was moved from some other repo, and this some other repo had almost 1,000 stars. So it is a good candidate. Even if we look even closer, we can see that it was developed inside Zalando, and Zalando uses it everywhere. So it's backed up by some big company, which is a good sign. So probably this framework is something worth analyzing. That is why I chose this framework to present here. So how to create this operator with this KOPF framework? So basically here with this KOPF framework, you don't have any, it will not generate you any of these CRD files, role bindings, anything. You are on your own here. So you have to implement everything, even the Docker file. So that is the bad thing. You need to, there is no scaffolding for that. But if you copy these files and fill them up to your needs and later maintain them, then the operator logic can be expressed in one Python file, and that is the operator logic for our operator. This is actually all the code, so it looks or almost all the code. So it looks quite good actually. If, as a matter of fact, I like it. I like it because like Python has these decorators which they smartly used in this framework, and where they specify on create, meaning okay, this function will be executed when the operator watching some resources, it sees that the resource was created, then this code is created. Also, this Python, you have this multi-line strings, so the Kubernetes configuration looks quite good here. And it is very concise. The whole creation is expressed in a nice way. So I must say I quite like it. If you want to build it, again, Docker build. We don't have this make install because this make install was the things from the supported by Operator SDK. Here we are on our own, so we need to apply all these files. And maybe it's good time if I show you all this. I'm all the time mentioning these boilerplate files, how they look like if you implement them on your own. So if you use this KOPF Python, you need to write your Docker file, which will be quite simple. And you need to, this is custom resource definition. So this is like a description of your custom resource. You need also to write all role binding will always be the same, but the role, meaning what permissions are required by your operator, and the operator logic, that is the whole logic. This create function, which was on the slide, we have a similar function for the update, and this but in general it looks good. I must say I really like this Python approach. So if you choose this KOPF, actually, if it's a good idea if you are a Python developer. So what it means to you, if you use in general any operator framework. So any operator framework is less popular than Operator SDK. So Operator SDK actually now it even used the cube builder, which was before used for building operators. So it's now the number one. So any operator you choose will be less popular. You have to deal with that. You have no project scaffolding, usually no boilerplate code creation. So we are on your own here. But you are using your language of choice. You are using imperative language, so there is no limit on functionality. So yeah, so I think it is still a good choice, for example, if you are a Python developer. So the last option you have is to write operator from scratch. So going hardcore and not using any, is going the hard way. So implementing everything from scratch using a bare programming language. Because since operator is just an application, if your language, especially if your language has some good Kubernetes client, you can write it from scratch, and people do it. People write operators in Kotlin, Rust, Node.js, and some in Ruby and all these other languages. So if one of the nice and interesting example what I found on the internet to create an operator was to use Java with the Quarkus framework. It is actually good because with the Quarkus you can compile it to the Docker native image, which helps you because it's at least you use Java, but it runs very fast. So, and it is a small image, so you can write in Java because, for example, you may like Java, but have the performance similar to the Go. That is why I chose this as an example. I will show you a link to the very good blog post which expresses step by step how to build an operator using Java with Quarkus. So you're on your own, so you again need to implement all these CRDs, role bindings, operator deployment files. Nothing will help you here. Yeah, and you implement all your classes, all your Java classes and the operator logic. How it looks like in the code. So the main part of the code in Java will look like this. So you need to, take all the deployments you have in your namespace, filter them, check, if the deployment is empty, then create a new deployment. If the deployment is not empty, then check all the deployments, modify the size and update them. So the logic is pretty clear, but as with everything in Java, you have to write a lot of different things. Like, for example, this, which almost is out of the slide. This is just, Quarkus providers. So like for the Quarkus dependency injection, just to provide the Kubernetes client. And again, you have write a lot of code, like for the deployment installer, for the caching the deployment, because nothing helps you here. And then the resource list, specification. If you like Java, you're probably used to writing a lot of boilerplate code, so maybe it doesn't look that bad. But in general, it's like you write a lot of code, and it's more difficult to maintain. The good thing is that if you already write this whole code, then you can compile it and run it and build a Docker image or build a Docker native image. And usually, what you will want to do is probably build a Docker native image, because otherwise, as with Java, you will have if you build a standard Docker image, then size of your Docker image will be high, and the memory consumption and all that comes with the JVM. But if you build a Docker native image, then actually the performance is very good. It's compiled with the GraalVM, and it's good. And all the other steps like applying this operator, running this operator, these steps are very similar to what we've seen before. So what it means to you, if you stick to the bare programming language, it will always mean writing more code. So obviously there is no limit on the functionality you provide, because you can write anything you want. But if you choose to do it, I see only one valid reason to do it is if you, for example, build everything in your company, you write everything in Java. You are really single programming language oriented. Then you maybe don't want your team to learn Go language or any other language. So maybe it then makes sense to even maintain some more code, maybe make it slightly more difficult, but for your company, for your organization, it may be actually simpler. Or if you need some library in your operator that exists only in JVM or in your language of choice. But if you do go this path, make sure that your language has a good Kubernetes client library, because if it does not, then it's even worse, because then you need to interact with Kubernetes API using REST API, like REST calls, and then it becomes even more difficult. So that was all I wanted to cover. So as a short summary for this talk, I would like to answer one question, like after listening, so which tool should I use for my operator? Because you've seen a lot of code snippet and a lot of different ways of building operator, but which one is the best? Because I can tell you from my perspective. So, it's like if I've seen all this code snippet, I'm a Java developer. So if you show me all this code snippet, then I would still use Java as a first approach, because this would be the simplest for me. However, I would actually never use Java for writing an operator. The reason why is that just most developers, they don't write operators in Java. So if I decide to use Java, I'm on my own, with all the bugs, with all the new features, with all the questions on Stack Overflow, I just don't have the community to work with. Then we can see, like, I did one exercise to check what other tools, popular tools, what other software, what they used for their operators. Like, for example, like Prometheus, a very popular metric tool, like they use Golang for their operator. What CockroachDB use? They generate an operator from Helm. Datadog, they use Golang. Snyk, they generated from Helm. Jenkins, Golang. Redis, Golang. So you see, even like a tool like a Jenkins written in Java, it's like they use Golang for their operator hosted on Operator Hub. I did one more exercise and just checked all the operators that exist in Operator Hub and see, how it looks like. And that is the outcome. So you see, like, most of the operators are written in Go. There is a big fraction written in Helm. There are some in Java, but like really the majority is Go and Helm. That is why, like, I would recommend, if you were to choose your tool for the operator, I have 5 hints to do. So hint number 1. If you already have a Helm chart for your software and you don't need any complex capability levels, then use Helm. That is what we did with Hazelcast. Currently, we didn't need any complex features. We had a Helm chart, so we generated an operator from Helm. Good enough, and no work required. Hint number 2, if you would like to create your operator quickly and you don't need any complex capability levels, again, use Helm, because Helm is the fastest way to get you from nothing to having an operator. That is clear, because Helm means just running a few Kubernetes configurations. That's it. Hint number 3, if you want complex features or be flexible for any future implementations, then do what others do, use Go, because it does not limit you in any situation. Hint number 4, if you would like to keep a single programming language in your organization, then if there's a popular operator framework, then you can contribute to it, and then just use it. But if there's no popular operator framework for your language of choice, then use just bare programming language. Hint number 5, if nothing mentioned, just implement it in Go, because people just use Go, so we are in a good company. And as a last slide for this talk, I would like to share the resources. So the first one is the most important, is these are the GitHub repo I created, where you can build all these operators using different frameworks with on your own, just to play around. Second one is the operator SDK documentation, where you can, which is like now going mainstream with the operator. Third one is a very good blog post explaining step by step how to build an operator using Java and Quarkus. And the last one is the documentation of this Kubernetes operator framework written in Python, for the Python, which is, I think it's actually a very, very good framework. So with this last slide, I would like to thank you for listening. It was a pleasure to be here.